Hello and welcome to another Oxford MAT Livestream. My name's James and today we're going to be looking through MAT 2020, which is last year's math submissions test paper. Hi everyone, how are you doing? You alright? Hi to people in chat. I can see Alejandro here and Aris and some anonymous people. If you'd like to join in with the live chat, if you're watching, we're over on slido.com/MatLive, MATLIVE is the event code over on Slido. Hi to George, hi to Jacob, hi to Molly and Lily. There's a little bit of lag on the chat. There's two sorts of lag. There's lag of it appearing beneath me and then lag between the video getting out to you as well. Nice to have you with us today. We're going to look at some questions. The way this works is there's going to be a poll to decide which questions we want to talk about. Quick reminder, that always means that we end up talking about the hardest questions or the ones that people found the most difficult or awkward or weird. If you've had a go at the MAT 2020 paper, I think it's overall okay. I think it's not as difficult as the 2019 paper in terms of what the average score was for people who took it. This is the whole paper, by the way, the 2020 paper, without the blank pages. And good afternoon, anonymous people, and Carol, and I can see Aki and someone with the username Lun, and someone watching all the way from China where it is 12 AM. Rose says, how am I? I'm good, thank you. Thanks for asking. We're going to do a poll in a minute. Since it's the last one, I have some bonus content. You might have noticed, maybe not, half an hour ago we managed to upload the video of all of the solutions for MAT 2020 as a kind of bonus content thing. It's about 2 hours long as a video, which is quite long for a video. We had a lot of trouble exporting it through video software and then uploading it to YouTube. I can see a couple of problems with it, but I know I don't have time to fix them. So let me know in the comments if you can spot what's wrong with the 2 hour video that I don't have time to export again. Hi Millie, hi anonymous person. Flora is also here, thank you for the reminder. Flora's here, moderating chat and talking to people. Flora is one of our current students. You've met Flora before on live stream stuff if you've been around. If it's your first time, hi. And hi to Flora. Bonus content, yeah, big video about all of the MAT questions. I've also brought along, a sort of show and tell, I've brought along to celebrate chat. Chat's been absolutely brilliant for the last 10 weeks of MAT Livestream. It's been 12 weeks? How long has it been? 12 weeks or so of MAT Livestream. It's been absolutely fantastic. I've brought along a little word cloud of everything that's been, well, the main things that have been said in the 5,000 things that people have put in chat over the last 10 weeks. Here we go, here's the word cloud. Let's all have a quick look at this word cloud. Have a think about what's going on there. I've just seen someone says, James's voice sounds like mine and my family thought I was talking to myself. Cool, I've never met anybody whose voice sounds like mine, so nice to know. Molly says some things. Oh yeah, it's people watching the MAT 2020 in 10 minutes or less video. This is a thing that we put on YouTube. We put it on the main channel. This is our second channel. We put it on our main channel. It's a 10-minute video of me saying all the answers to the MAT test as fast as I can. Each year it seems to weirdly get picked up by like the YouTube algorithm and get seen by a weird number of confused people. So that's fun. Good luck to everyone taking the MAT as well, says Molly. This week you got all of the 2020 MCQs right. Well done, Molly. There we go. Cool. Someone says it's the first time they came to a live thing, which is nice. B says they like question 3, which is good. Yeah, where's the complex numbers? I like that comment. Where's complex numbers? We've just got like maths in big and then some other stuff we talked about, I guess. Oxford is here. I think hilariously Oxford has been put on this chart in automatic chart in Cambridge blue. Flora made it on as well. Well done, Flora. You're in the word cloud. Maths is in there. Mathematics. Personal statement I can see. Questions. International, which is nice. Makes me feel like Mr. Worldwide. Mathematical's in there. I can see computer science. Probably those paired together a lot. Infinities in the word cloud. And lots of other stuff too. Oh, inspirational quote of the week. Right, okay. Yeah, fine. Thanks, Flora. I think I said it to someone in chat just now. Let's put it on the screen as well. It's a maths test. You're great at maths. No, you really are. You're choosing to watch weird maths videos in your spare time. You're definitely great at maths. You've got this. Complex numbers didn't make it into the cloud. Yeah, I know. But despite all A levels, what A levels did the complex numbers have? Despite all of our like running jokes and memes, what's going on? Yep. Okay. There was a technical question there about getting math scores. Chat's really excited today, which is nice. People are now saying complex numbers in chat to try and get it up. Small values of n also. That's a good shout. Okay. Yeah. Okay. There was a comment in there about 2.5 hours. Yeah, look, this is what people say about the 10-minute video as well. James solves it in 2.5 hours. I did not. The video is 2.5 hours. That is not the same thing as me doing all the questions in 2.5 hours. Editing, magic of editing, especially the 10 minutes. Cool. There are some really good questions coming in here as well. Good. Okay. I also brought a list of like the top comments, the things that got the most thumbs up. Don't try and beat this now. This is the list. There's no, don't try and beat these with high scores now. The top comments from MAT Livestream 2021 were like this comment for fractions bigger than decimals, if you believe that fractions are bigger than decimals. And then hoping recursion's not on this mat, no comment. And then putting it on Spotify, never did that, sorry. And then the only person on here is not anonymous. Aris, well done. You've got the top comment by someone who put a username down. It was from the logarithm session. Aris's joke, I'm really glad I logged on for this, was the top rated pun. Cool, okay. We're going to do a math question now, I think. Quite enough of that. What's chat saying? People here for Tamua help as well. Tamua is another maths test that uses multiple choice questions. Oh, let's do the how's your day going. Let's do that poll. I like that poll too. How am I doing? I'm doing well, thanks. Oh yeah, if you're not applying to Oxford, this was a question behind this poll. If you're not applying to Oxford, you get your math score back from Imperial or Warwick through their feedback process. That is written on the internet somewhere. But if you're not applying to Oxford, hey, welcome to the Oxford live stream. You need to talk to the universities you are applying to. They've got a normal feedback process. Our one is a bit more automated because we've got thousands of people who want their math scores, so we automate sending out the math scores. I think Imperial and Warwick, I think you need to ask for it as part of their feedback process later at the end when they're done with their admissions process. Okay, cool. People's days seem to be going quite well, which is nice. Look at these 4 stars and 5-star votes. It's like 70% of people having a nice day. That's great. As always, I'm looking out for the 1-star, 2-star people as well. I hope your day gets better. I hope that things work out. And yes, cool, good, okay. Oh, I like watching this graph shift around. There's something quite pleasing about the way the bars, because it's percentages, whenever somebody votes, all the bars move a little bit. Quite like watching those go. Right, okay. Do I need to do a shout out to 3-star people who voted 3 stars? I need to refresh this because my poor little chat window is overloaded by chat. Okay, maybe I should turn on this poll. Oh my word, do I want to install the... No, I don't, right, okay. I think it's maybe time to vote for which question we're going to do. Voting for this is a little bit different. You can vote for as many options as you like. You can see what other people are voting for, I hope. So someone's voted for question 2. You can vote for multiple things. Normally people end up voting for the ones that they most want to see on the live stream. We're going to do maybe 6 o'clock, maybe 6:30. We're just going to go now for the next hour and a bit talking about math questions in the order chosen by you, the viewers. My day was going all right, and then I realised we had a math live stream, and that's made it good. Okay. Oh, thank you. I've missed this, but someone said something very nice about the math live stream. Who is this? Who said something nice? Alejandro says something. Meredith said something very nice that is getting lots of thumbs ups, which is very nice. Yeah, and X plus IY is sad that it's the last one. Easy 5 out of 5. My day's going fine today. Today is... Well, we've got the video working, so 4 stars. I spent too much of today messing around with video editors. Pro tip, if you're using a free video editor, don't make 2-hour videos with it. They're not built for that. Cool. We're learning so much along the way. Learning about YouTube, we're learning about live streams, learning about video editing. There's so many people here right now, and so many people voting. Question 2 is currently winning, and it's not close, I'm going to say. Let's have a quick look at question 2. Oh, question 2! So, question 2, I think disappointed people, or upset people a little bit last year, that it has this thing about binary. since then, lots of people have been asking me about whether binary is something that's okay to ask about. And I'm going to point that, okay, binary is not explicitly on the syllabus. It doesn't say binary, but we thought, when we wrote this, we thought that people had probably seen binary before, and we're not asking you to do anything very advanced with binary. And there's a reminder about what binary is and how you write 13 in binary. People liked question 3, which is good. It sort of means we might not do question 3 because people liked it, although it is coming second in that vote. Yeah, I quite liked question 3 as well. Okay, enough voting. Let's switch chat back on. Check everything's okay. Anything on fire? No, good. And people are, yeah, please, I'm stuck on question 2. We're going to talk about question 2. Let's go. Okay. And if I've missed anything, Flora's going to star it. If you asked a really good question, but I missed it through all the kind of fast-moving chat, if I miss your question, it might get starred, and I might come back to it later, or answer it offline after I finish being live. Cool. Okay. I watch some live streams, and it's really hard to respond to everything in chat as well as doing a live stream. So, okay, I need to start talking about maths. Let's go. We've got 2 functions. We've got f and g. F takes a number, doubles it and adds 1, and g takes a number and multiplies it by 4. Okay, those are our 2 functions. The question is about the numbers that we can make. So it's not all of the positive integers, maybe. Well, maybe it is. I know it's probably not, because I don't think we can make the number 2. I think we can't make the number 2 with these functions because when I plug in 1, I'll get 3 over here, 4 over there, and also when you plug numbers in, they get bigger. So I've missed my chance to make 2. I made 3 and 4, and now I can only make bigger numbers if I apply f and g again. It's part 3, and you said something nice earlier. So part 3, we'll get there. Okay. This question is about the set that you can make by applying them. There's this thing about applying the functions. So there's this notation for applying lots of functions. You might be more comfortable about this. This is a slightly compact notation, which you might be happy with this if you imagine there being lots of brackets inside, like this. So this is what this means. I'm going to give you an example to show how that works. That this is the queue of functions that are going to apply to the number, and it's going to come in. Okay, that's an important question at the top that I'm going to come back to. Zach knows how binary works. Called it base 2 as well. Cool. Okay, we got functions applying. Anyway, first part of the question is to write out 100 in binary. This means writing it. So the example here is to write 13 as powers of 2. I know that 100 is it's bigger than 64, and then there's 36 left over. 36 is bigger than 32 and 4. I think we gave people a mark for writing that, or possibly we then wanted them to actually write it in binary, which means this is 64, 32, no 16s, no 8s, a 4, no 2s, and no 1s. I think 1100100 works well, I think. Okay, we end up with this number in binary. Some people wrote a little 2 down here. We didn't dot marks if you didn't write the little 2 down here. We didn't even write it in this example, I suppose. Okay, is that top question, can you use pencil? I think the instruction on the front of the test is to use pen. This year the tests, because we're doing remote things because of COVID, the tests get scanned. If we can read it after it's been scanned, then we will mark it. You can make that easier for us by using a pen like it says on the front of the test, please. But you don't get like automatically rejected if you use a pencil. We just makes it a bit harder. Please use a pen. Okay, cool. Right, was that a bit too flippant? Never mind. Okay, part 2. 100 is in S, so we need to find some F's and G's, and I think the strategy of messing around with F's and G's works for this, because you can make numbers like, well, we're done if we can make 25, because if we can make 25, then we can go from 25 to 100 by multiplying by 4, which is what G does. So now the question, I guess, is can we make 25? And I think I can make 25 by starting at 12 and applying F. And in fact, I think the thing that you want is GF of 1. So those 4 functions applied in that order. Aha! What's the average score I'm expecting? What's the meaning of life? Yeah, okay, I don't know. To either. I think both those questions are really hard. Good. This is fun. It's part 3 that's hard. Part 3 is to show that 200 is not in S. So no matter what sequence of F's and G's I apply, I can never hit 200. Which is maybe a little bit surprising because there's lots of different combinations of F's and G's I could try. I could try 27 F's and then 13 G's. I could try F's and G's alternating for 200 times. There's loads of things. We're going to need to prove that we can't do it. This says show that, and I saw that you asked that question about explain earlier as well, which does mean, these all sort of mean the same thing, prove something. Explain why, justify, show that, prove that. Explain why this is true. Is this or not? Explain your answer, justify your answer. These things all mean you've got to convince us. So here there's kind of a given statement, right? 200 is not in S. You've been told that. If I just write 200 is not in S, that's not a question. So the question here is to explain why 200 is not in S. Okay, so we're going to do a little bit of a proof, but let's not be scared about what a proof is or what it means to prove something in a strict mathematical sense. Really what we're looking for here is that you can explain why 200 is not in S. There are some reasons you can give for why 200 is not in S, and there are some things that are not reasons. So you might say, if you might write 200 is not in S because 200 is even. And that sounds like an explanation, but it's not true. S contains some even numbers like 36. So you see that's not an explanation because it doesn't actually explain why 200 is not in S, even though it's got kind of the cadence, the rhythm of a proof. Okay, so show that 200 is not in S. Okay, so we need to prove that no matter what sequence of F's and G's we've got, we can't get to 200. Here's a good idea, which I saw, I think Zach say in chat a while ago. Think about the last function applied. Can't be F. So we're going to sort of work backwards, like I did for 100, I suppose. Let's target 100, now target 200, but slightly different to show that it can't happen. It can't be F. Why can't it be F? Well, F always gives us odd numbers. We put a whole number in, we get an odd number out. 200 is not odd, so it can't be F. Okay. I saw a combination for 100 flash by in chat as well. Looked good. Okay. Good. Can't be F last. It's going to be, so let's think about what happens if G is the last function instead. 200 is G of 50. We're going to show that 50 is not in S. This is a sort of bold claim. Think about the last function again. Okay, so this is kind of my 2 steps. First up, I hope you're following along. We're thinking about the last function. It's not an F that happened last. You know, all the possible sequences that we have, the sum function applied last, stop writing, have you hit 200? Well, your last step wasn't an F because 200 is not odd. So it must have been a G if hypothetically you'd done this. G of 50. 50 is not an S. Here's why. Because think about previous function. So like the one before last. That can't be F because 50's even, and it can't be G because it's not a multiple of 4. So 50 is not in S, so 200 is not in S. Okay. Somebody asked about how much explaining or show that you need to do. What's a mathematical proof? What does it mean to prove something? The amount of writing I've put in this on the screen, I think is enough for this. Maybe it's more writing than you would do, or more maths than you'd like, more words than you'd like to see. But look, this is about. I suppose this part of the question is tricky because it's about the idea of looking at the last function, and then looking at the last function but one, to say how did you get to 50? How did you get to 200? What was the last thing you did? Having that idea is the important part of the question that you get working out marks for having that idea, even if your answer doesn't quite make sense. But having that idea, you get some marks along the way. The MAT is marked, by the way, by graduate students at Oxford. I get graduate mathematicians and computer scientists to mark the MAT because they're really good at identifying whether your argument, the thing you're writing down, whether the statements you're writing down, whether that makes sense or not. They're really good at that. And they're very good at maths, so they know lots of different tricks you can try. There's a different trick for this, which is to think about binary. Depending how you feel about binary, it's not a proof if you don't put a little square at the end. Okay, I'm going to draw a little square. There you go. And we're going to write QED as well. There you go, put some Latin in. There we go, now it's maths. That was a joke. Right, cool. Yeah, so Xander, I agree with this. In binary, 200 looks like this. And I can work this out quickly because 200 is twice 100. And doubling is easy in binary. 200 looks like this in binary. But in binary, f and g are actually very simple functions. In binary, this just means write 1 on the end, because the doubling shifts everything along in binary, and then add 1, writes a 1 on the end. And g of n over here, multiplying by 4, writes 00 on the end. So if you start with 1 and then you just write 1 on the end or 00 on the end, then the things you can make have 1s in or double O's. The O's all appear, the zeros all appear in double O's, like in Bond. Whereas 200 has this string of 3 zeros at the end, which means you can never make it because you can never get an odd number of zeros in a row. The functions only write 1 or they write 2 zeros at the same time. So some people did it like that, which is it's a completely different argument, sort of. It's a slightly more advanced argument because it involves binary, which some people don't really like, and also because it shows you can't do other numbers as well. It's a more precise statement about which numbers you can make. Okay, is binary in A-level? There's a question in chat twice, and people are replying to it. Let's find out what people are saying in chat. People say no, not in the full syllabus. Some modules might contain it. We thought at the time that some people might have seen it in GCSE. It's binary in the MAT syllabus. I guess it's... I see, one of these questions says is binary in the MAT syllabus, one says A-level syllabus. We think that some people learn about binary in GCSE, and we did put this reminder in. Also, this was not worth very many marks, and you can do the question without thinking about binary. Okay, how are we doing? We've thought about part 3. 200 is not in S. We can't make all of the numbers in S, all of the numbers, because we can't make 200. Carol wants to do part 4 with this solution. If the g function is responsible for even numbers, they're multiples of 4. Yeah, okay. So the numbers you make are either odd or multiples of 4. Yeah, and it's not actually all of those, but it does have to be one of those, odd or a multiple of 4. Just thinking about the last numbers. It's not all of those, and it's not 200 in particular. A shame. Okay. How do I get rid of bias in the map? For example, if someone's dad was a graduate, well, so mostly we would have no idea that their dad was a graduate because we don't link that to their application. Also, the people marking the test don't know who you are. Cool. Oh, Flora's coming. Have a go. I can't answer it. Flora's going to start. Thank you, Flora. You're doing a great job. If your question is long or refers to admissions, Flora's not really equipped to do it. So Flora is helpfully starring them so that I can come back to them when I'm paying more attention to chat. Sorry if you miss it. The stars are invisible. You can't see the stars, but they are there. I currently have, let's have a quick check what my backlog is. Thank you, Flora. I have 10 questions that are stars to come back to. Sorry, everyone. Okay. Yeah, and please don't spam Flora. Is everyone be nice to Flora? Yeah. Okay. Oh, what does elements of S mean? Elements of S. So S is a set of numbers. S is a set. And sets contain elements, the things inside that set. So it's a collection of numbers. A bit like you might say the set of even numbers, the elements there are the even numbers. Or a set of everybody watching today, the elements are Lun and William and anonymous people and X plus IY and everyone else. Sort of the things that you can hear, because of what S is, it means the numbers that you can make by applying F and G. There was a definition of S that I didn't read out, which was rude of me. Definition of S up at the top of the question. It's on screen now, but now it's going away because I'm going to scroll down to part 4. Okay. Part 4 caused a lot of problems as well. It's tough. And then 5 and 6 involve some tricky manipulations. I think I want to talk about 4. Yeah, people say maybe exposing things to 4. Cool. Okay. Right, exposing things to 4? What was that sentence? Complete nonsense. Right, show that if a number's in S, there's only one combination of applying F's and G's. We've actually had most of the idea already. We're going to work backwards. And the number that you're working with is either odd or multiple of 4. Oh, come on, multiple of 4. So as you work backwards, that thing's either been made by F or made by G. There's no confusion about what was the most recent thing used, and then you can undo that because you can undo F and G and work backwards through smaller and smaller numbers. So this is actually not too bad. So 67, we can see that the last thing that was applied must have been F. So it's this F. We can notice that because 67 is odd. 67 is odd. And then work backwards from 33, I suppose. But 33 is a smaller number. So if we make the number smaller and keep working backwards, then we're okay. We can keep making new numbers. Okay, I would write some of that in my explanation in rambling sort of 2 sentences at most, explaining how that works. Some people try to convince me when they were marking it, is g f of x equal to f g of x, which is a true fact. These things are not the same, but it's not quite enough, unfortunately, because of things like we need to check that f of x is not the same as g of x, which is not something that you cover by just checking that they don't commute like that. Okay, working in binary means you just read off from the binary number. Where's 100 gone? There's 100. From binary you just read off, starting from the 1, ignore the 1, and then read off FG, FG as you go from left to right. So if you write it down in binary, then yeah, I agree, SV. It's a little bit more obvious. Anonymous, 2014 and 2015 MAT with question 6. I think those are the truth or lie questions, which some people really like. We haven't talked about them on the MAT Livestream very much, but there's these quite fun people wearing hats and writing numbers and vampires and werewolves. The 2015 one is quite hard. I get lots of emails of people asking about 2015 question 6. And since 2015, question 6 has been a little bit different. We haven't done a truth or lie question since then. And I think that's all I want to say. Cool. And this person is 10,010 years old. Possibly in binary, but who knows? Good. Is writing too much explanation a bad thing? No. I mean, it uses your time, but you don't lose marks for writing too much explanation. Yeah, no. Good. We're nice. If you've worked out what's going on, you should get marks. If you've had ideas, then all good. Okay. Let's talk about the ideas for parts 5 and 6, because I think that's important. There's some technical manipulation going on in 5 and 6 where you can pick up some marks by just doing the manipulations correctly. So here, UK is the number of elements of S that lie in the range, so some range between some powers of 2. Still feels quite binary, but hey. Show that this number, the number of elements, what is that? So that's the ones between 2 to the k plus 2 and 2 to the k plus 3 is equal to the sum of the previous ones. My idea for this one is, where did these elements come from? So it's these elements in this range. Where did they come from? It's something I've been doing all the way through this question, thinking about what was the last thing you did? Was it F or G? It's one or the other, we've been saying. It's a unique way of constructing this. And I quite like the way that If it's G, then it was made from a smaller number by a factor of 4. If it was an F, then it was made from a smaller number by about a factor of 2, 2n plus 1, about a factor of 2. So that kind of lines up with this previous interval being about half, the number's about half the size, and this previous interval being the number's about a quarter of the size. There's some technical stuff to check that it's precisely the same by checking the intervals carefully. If you want to see someone check all the intervals very carefully and waffle a little bit, then the long video that went out on the channel an hour ago has more detail on me arguing about inequalities a little bit, and talking about one-to-one matching between precisely all the things in the previous interval linking up with the odd elements of here, or the ones before linking up with the even elements over here. Oh my word, yeah. Well, this comment, if you do G, it comes from UK, and if you do F, it came from UK plus 1. Yeah. I'd give you a mark for that, at least 1 mark for having that idea. Some technical marks to follow up by actually checking that the inequalities actually work, because F actually doubles and adds 1. Is the adding 1 a problem? It turns out no, but good. Right, it's Peter's birthday. Happy birthday, Peter. Could be worse. Good. Question about Alice, Bob and Charlie. Oh, and Alice, Bob and Samantha. Oh, look at this. Oh, JDS says, I saw a question about Alice, Bob and Samantha, and I wondered what happened to Charlie that they had to get a Samantha. My word. Okay. Yes, SV has got this sort of notice that this looks a bit like Fibonacci numbers, which is true, but it turns out not helpful. It's unfortunately in that category of somebody's just asked about using maths beyond the syllabus, right? So if you notice that this is the rule for Fibonacci numbers, that's kind of beyond the syllabus. It's not on the math syllabus. It's also not very helpful. So once you've noticed that it's the Fibonacci numbers, you still got to explain where the things come from anyway. You've got to explain why it's this. This is show that again. Look how many times this question says show that. It says show that here, and here, and here, and here, and here. Not in the first bit, but then all over the place. All these questions say show that. So it's like explain or prove. Good, right, okay. So I've kind of brushed the details under the carpet there, but I want to tell you the idea for part 6 as well. Whether we can get the technical details to work is, I think, less interesting for a live show, but let's talk about the idea. So SK is the number of elements, this is basically the same sentence, that lie in the range, but now the range is different. The idea here is that SK is made up of all the elements in lots of different ranges. The UK ones were restricted to be between powers of 2, but we can make it work by saying, aha, the relationship between the thing in the previous part of the question and this is that SK is the sum from U0, U1, U2 all the way up to UK. Add them all together and see what we've got. Not very original with their phrasing. Yeah, we tried to repeat the phrasing to make it more similar to the previous part. I like it when using the previous part of the question is a thing, because it rewards you for following the thread of what's going on. I guess important note, if you skip part 5, if you just ignore part 5 and go on and try part 6, to say, well, I have no idea how to prove this, but I'm going to use it in part 6, that's okay. You can get all of the marks for part 6. You're allowed to use previous bits of the question, and you're allowed to skip parts if you want to. You can still get the marks. We mark the parts of the question separately. Okay. So it's sort of independent. You can, if you're having trouble, you can leave a gap to come back to it maybe, or not, and then go down further and try the next bit of the question. Okay, now I've got this SK as the sum of a bunch of stuff. I want to use the previous part. I can sort of see what's going to happen a little bit. There's some technical details. I'm worried about this +1, right? That sort of screams technicality. But the shape of this expression is very similar to the shape before. And SK is secretly just a whole bunch of UKs in a trench coat hiding together. So really, if I expand this, forget this new S letter, if I expand this into the U's, suddenly I've got a whole team of things that I know facts about. I know facts about these UKs from the previous part of the question. I can use that previous part on each of those, on as many of them as I can, and then hopefully I can zipper everything back up together, put them back into two different trench coats to disguise them as these two S things on the right. And I think the one means that for technical reasons, when I try and put them into the two trench coats on the right hand side, there's a leftover bit that doesn't quite match up with how I want to split those terms up. I think I'm worried about this U0. I can't split that into two terms because this thing only works for U2 and upwards. Okay. With all of the writing... Oh, right, hang on, here we go. All the writing across the page and no clearly distinctive answer areas. It's true. I should say, while there's questions here and I'm doing this, you get to answer on blank bits of paper. So that you can see the question I'm writing. I'm doing a horrible thing of writing all over the questions. You get a couple of blank pages to write on. We don't lay out where you have to answer each part to give you a bit more freedom of how you're going to use the space. How do people marking them at know what question or part we're answering? So each question comes with a couple of blank pages. So normally you'll answer the question on those blank pages and we'll know what you're doing. We also know what the parts of the question are when we're marking. Sometimes people label them as they go through. So sometimes people help us out by saying part 6 like that and then doing the work. But even if you don't, we're marking hundreds of these and we know what the parts of the question are, so we'll work it out. If you need more space, there's other blank pages for other questions and a couple at the back if you're not using question 7. There's other blank space in the booklet for you to answer those on, and we will look through and find your work. If you answer all the questions in random places, we will still mark it. We will do our best to find where you answered the bit that we want to mark. Give you the marks like normal. Imperial questions are... Oh no, imp question? What imp? Imperial question, right? Are the sheets in the mat... Important question. Are the sheets in the mat book detachable? No. The booklet is a booklet. It's slightly bigger than A4 and it unfolds to be slightly bigger than A3. It's quite big. You write in that. It is stapled together and then it gets posted and scanned and all manner of things to get to us, where we mark it. Okay. Use previous part, zip it back together. An interesting question would be, if I just wrote this, and didn't actually do the maths, how many marks do I get? I think I maybe get 1 mark for this, and I maybe get a second mark for this idea. I think I've possibly got 2 marks by doing that. Having ideas is important. And you can get method marks on these things for having an idea about how you're going to do things. How many marks should we aim for? I always aim for the stars, 110. It's out of 100. A good score is somewhere like 70 or more is usually a good score. Is math just based on first year A-level maths? Yes. We have a syllabus actually. We have 1 page of A4 maths, 1 page of A4 with maths on that we think people have seen. We've been covering it on the MAT Livestream. It's also on the MAT page. If you go to the MAT Live page down there, you can find content on what's on the MAT syllabus. It's mostly just first year maths, plus also sequences and series. We did a live stream about sequences and series for you to see what we're talking about there. Cool. I don't really get part 5. Yeah, 6. Sorry, Roman. Rose, don't really get part 6. Yeah, I haven't really done part 6. I'll give you more of it. I'll help you out. So the left-hand side, this sk plus 2 means all of the elements up to 2k plus 1. Aha! That interval is 1 less than or equal to n less than 2, or 2 less than or equal to n less than 4, or 4 less than or equal to n less than 8, or and so on and so on and so on. So this sum, for how many, this s, a small s number for how many there are, is u0 plus u1 plus dot 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 dot, plus I think the last one is uk plus 2, using the previous things about how many there are in each range like that. Then I'm going to use the previous fact. So u2, instead of writing u2 this time, I'm going to write u1 plus u0. Instead of writing u3, I'm going to write u2 plus u1. And instead of writing uk plus 2, I'm going to write uk plus 1 plus uk, which is a bit of a mess. Then I can take, this is a bit of a mess, but I can take the first term from each bracket, and the first terms from each bracket add up to exactly sk plus 1. This sort of sum is true for other stopping points. The other terms in the bracket, starting here, are sk, and then I'm left with just u1, and u1 is equal to 1, so that's where the things on the right hand side come from. You have to be really careful as you do this. I've been very systematic, and I've got my little brackets, and I've got my circling going on to show you what I mean. But ideally, maybe you would write a little line, take the first term of each bracket or something, or just do it, and look, if it looks good, then it's probably fine. That's the maths for showing why this thing works. I've done that quite accelerated and quite compact and neat because I've done it a few times now, so I know the kind of shortest thing to write down. When people actually did this question, they wrote usually quite a bit more of sort of messing around with the terms and adding things in and subtracting, or messing around, trying to make sure that it all worked out to give the stuff on the right hand side. Some people expanded the left hand side and the right hand side and compared them, which is fine. You still need that fact at the bottom, u1 is equal to 1. Okay, how many colleges are there? There are 29 colleges that offer mathematics, and there are a few more. And then there are some other ones that are not quite colleges. Ha, right, but for maths, 29. What's my favourite math paper? I quite like 2018. I can't remember all the questions on 2018. Or is it 2019? I quite like 2018. Okay, right, cool. Question 2. I think we got there. Let me know if that was better, Rose. I'm not really sure. Someone says, technical question. Are you suspected of cheating if you tore a blank page from the booklet? Oh no, I see. It's because B did a logic question, moving a small bit of paper around. I don't think that's cheating. So no. Okay. How many people take the MAT? About 5,000. 5,000 is quite a lot of people, isn't it? X plus IY likes 2018 too. Was 2018 a really high average score? People tend to like the ones with a high average score. 2020 had a slightly higher than average. 2019's got that triangle one, hasn't it? Which I wrote, so I've only got myself to blame. What is that? Okay, right, let's vote again. Oh, that was helpful. Good. Right, okay. You guessed? Oh, you guessed it because of lag. Cool. Let's vote for what's next. Oh, and I'm going to edit the poll to remove question 2. It's still there. It's gone. Oh. So now question 3 and 4 are winning the poll. We're doing a bit more voting. Does each college have about 50 seats for maths and computer science? No, sorry. Each college has, on average, about 6 or 8 places for maths and computer science together. Oxford's not a huge university, so altogether we've got about 180 places for mathematics and a few more for the joint honours courses, and about 40-50 for computer science and things. So sorry, maybe fewer places than you think at Oxford. There are stats on the website. Cool. Yes, right, okay, let's do this question. Often need extra paper. Is this allowed? When I was doing the mock, initially said that in the real thing I wouldn't be given extra paper. Okay. Sounds like an access requirement. Talk to your test centre about modifications, reasonable modifications. If it comes to it, you're not really supposed to use extra bits of blank paper, but if you've got a clear reason for doing that, it sounds like you've got a clear reason for doing that. I think technically we should have put that through as an access requirement because you have like an access requirement for that. If you do it and it makes it to Oxford, then we'll mark it. Talk to your test centre about trying to get that arranged, rather than just doing the thing. Sorry. Okay. I think that's best I can do. And someone has put in chat, ask your test centre. Yeah. Aki would like to see some multiple choice questions. I quite like the multiple choice questions as well. All the long questions are winning in numerical order. Oh no, except 7. Sorry, 7. We could speed run question 3. Question 3 is quite quick. How do people feel about 3? 3 is cool because elliptic curves are cool. Have I written any long questions for the MAT? I'm not sure if I'm supposed to comment on that yet. Happy with the MAT last year, it's like this year. And there's a question about waffling. How waffly can answers be and still obtain marks if the waffle isn't very technical? I think that's fine. If you've had the right idea, if it's clear from reading your waffling that you've had the right idea about how to make progress with the thing, It's a bit like that in interviews as well. If you're talking and you've had the right idea, that's much better than if you don't say anything. Cool. It's for the one. Are Bob, Charlie and Alice still asked on Matt? They are quite confusing, question mark. I love that. I love that let's switch that back on so that it's in the video. There we go. Are Bob, Charlie and Alice still asked on the Matt? They are quite confusing. We haven't done a question with Bob, Charlie and Alice for a while. These are the kind of logic questions about hats and numbers and things. Yeah, I haven't done it for a while. Oh, I can do that to Zoom. That's nice. We're going to talk about question 3 very quickly. I like question 3. There's this scary picture of a curve. I think it'd be really scary if we asked you to draw this. But you're given an equation as well. So lots of the question comes down to working with this equation. Okay, what happens if you forgot to put your middle name on your UCAS application and you didn't know? That's fine. You're fine. You're fine. We can work it out. Names are very complicated, and one of the nice things about having UCAS numbers is that UCAS numbers are less complicated. Still quite complicated. Cool, okay. How many people make it to interview? About 3 people per place make it to interview for maths and that sort of thing. About 3 people per place. Okay, cool. This is sort of just a roots of polynomials question. Yeah, we're gonna do polynomials as our way into talking about this question because we know some facts about polynomials, and it turns out we can get quite a long way with polynomial stuff. Okay. This is just a roots of polynomial question. Maybe we'll get an XYZ question this year. Are computer science students... let's say the thing. If you're doing computer science, then you don't answer... If you're applying for computer science, you don't answer questions 3 and 4. You answer questions 6 and 7 instead. If you're applying for maths and computer science, you answer questions 3 and 6. You don't answer question 4 or 7. So everybody does 5 questions total if you count question 1. Right, okay. We're going to talk about question 3 anyway because it's just polynomials. You could do a version of this, not all of it, but some of it could be a multiple choice question 1 sort of thing. That's how I normally justify doing this sort of thing to computer scientists. You might get something like this on question 1, who knows? Right, let's get the ball rolling. We're asked about A and B, which are the points where y equals 0. Y equals 0 gives us a great way in because now it's a cubic for x. Cubic for x equals 0. So some cubic for x equals 0. We can solve that to find those numbers. I think they turn out to be -1 and 1. Part 2 wants us to talk about this part of the graph where the curve exists, which is a little bit hard to think about. The curve only exists for particular values, and I thought about this for a long time. I thought, well, what's going on? Because x, when you change x, this thing on the right hand side can be any number, because x cubed minus x takes all the values. But as you change y, so maybe you're scanning around different x, y points to find out if they're on the curve, this y squared minus y thing, it has a minimum, it's quadratic. So there are some problems I can run into. If the thing on the right is very negative, which it sometimes does, it's a cubic, if it's very negative, then I can't hope to get any solutions at all for any value of y, because this thing's not going to be negative enough. That's my idea. I can turn it into maths by completing the square, by trying to be precise about how negative is too negative. If this thing's very negative, then there's no solutions, because the left-hand side can't be very negative, which is why there's no solutions over here. There's no bits of curve over here, because x cubed minus x is very negative, so negative y squared minus y, so I can't go that negative. Is it negative that I mean, or is it less than some number? Let's find out. The left-hand side has this minimum value, which I can get by completing the square. Its minimum value is -1/4, so that's the problematic value. If this thing on the right goes below -1/4, there's no solutions. So let's write that. No solutions if x cubed minus x is less than -1/4, and then those special points, well, they're right on the boundary. They must be when x cubed minus x is equal to -1/4. Aha, okay, which gives us some cubic. In fact, this is the cubic for part 4. This is the cubic that I'm looking for to work out where these points alpha, beta, gamma are. But for part 2, I'm just interested in the fact that, well, when that's equal to -1/4, y is equal to 1/2 there. because y minus 1/2 squared is 0. So y is 1/2. Okay. Yeah, cool. Okay. Explaining why it's symmetric, I think the fastest way that people wrote down, that I didn't really see coming, was to just try and rearrange this. To write down, we've got this, complete the square thing. It's brilliant because we can just write down this. This is only true if the thing inside the square root is positive, of course, or 0. But it's got this plus minus sign in. And the plus minus sign, I'm writing really small. There we go. The plus minus sign is good because it gives us that symmetry. For every point above, there's a point below. So that's why it's symmetric. You can also argue by talking about shifting it and flipping it and doing stuff like that. Different ways to think about symmetries. But really, writing the equation like this gives you access to solving for y, which is quite nice. Okay, cubic equation, we're doing well, we've got that one. George wants to use implicit differentiation, which, don't be scared, everyone else is not on the math syllabus. George, I think, is using the fact that the derivative vanishes there, which does work. Oh, sorry, the derivative is infinite there, or really large nearby or something, which does work. You would need to differentiate both sides to find out what y by dx is, and then say y by dx is really big, so this thing must be 0. So y is 1/2. I think that's what George is doing. Goodness knows. Right, cool. Acceptable, but not really using maths that I expect everyone to have seen. Ooh, who is scared by that? Have a quick look at the number of viewers. Everyone's just logged off, having seen some implicit differentiation. If you're in year 3, ooh, everyone's in. Anyway. Ooh, Alex, technical question. Technical questions. Send your math questions. I'm going to star that. That's a classic, Alex. Classic thing to get starred. You can't see the star, but I've starred it, so I remember to come back. If I don't come back live, I will type an answer. Cool. If anybody else is interested in the answer, then check the Slido afterwards, or wait for me to say the answer. Right, cool. What are we doing? Oh yeah, we've got a cubic now. So now things really worked out because we've got this cubic for alpha, beta, and gamma. We're asked for the value of alpha plus beta plus gamma, but we're told to do it by considering the factorisation of this cubic. So that's not too bad at all. We've got this cubic, x cubed minus x plus 1/4 is equal to 0. But we also know that it factorises. It's got roots alpha, beta, and gamma, so we know that it factorises like this. I'm being careful. It is like this because there's not like a number out the front, because the coefficient of x cubed needs to work out to be x cubed. This must be how it factorises, since we know the roots are alpha, beta, and gamma. If you multiply that out, and compare coefficients, you don't actually need to multiply it all out, I suppose, but it's not that bad to multiply out. Especially compare the coefficient of x squared, and you get 0 is equal to minus alpha minus beta minus gamma or something, which means that that sum is 0. Okay. Yes, there's something called Vitas formulas, which some people learn and some people don't. We talked about it when we were setting the question, but we thought that because you've got a factorisation, we told you to factorise it. Once you've written down the factorisation, you might as well multiply it out and compare coefficients. We think that comparing coefficients is something that everyone's seen. Okay, good. What type of circumstances are taken into account? Yeah, that one gets starred as well. If your math score may not be the best. Cool. Comparing coefficients is a thing you can do with polynomials, I guess. Yes, good. I don't really get part 4. Okay, well, so my cubic equation just came out of this way of writing the expression. If you're at the line y equals 1/2, then this chunk is 0. So that just gives me a cubic equation. It's quite nice. If you're looking for a point where this hits its minimum, that's y equals 1/2. So delta's 1/2 on that line. And at that minimum, well, this thing's 0, so it simplifies to some nice cubic. So we get this kind of expression for what's going on for those special numbers. Okay. Part 6 is a little bit different. It brings in this circle. The key idea is to write down, I think I'm not going to do all the algebra live on stream, but we'll write down the circle. They even tell you to do this. So write down the circle's centre and radius. Oh, is that O for comparing coefficients? Or by comparing the factorisation. Maybe this is news for people. Comparing the coefficients on this is weirdly powerful. You get this fact about the sum of the roots of the thing. It's quite nice. It's a little bit like for quadratics. When you're factorising a quadratic, you think about the sum of the roots and the products. It's sort of like that, but for cubics, or for just polynomials, right? You can write down the roots like that, multiply out, and you find out facts about how the roots relate to the coefficients. Somebody's got their name on that, Vita, but you don't need to have heard of Vita's formulas to understand that there is some link between the roots of an equation and, via factorisation, the coefficients of the polynomial. Okay, right. What was I doing for 6? Oh, we're going to write down the circle's centre and radius, so we get an equation for it, and then set it equal to the solve the simultaneous equations of circle equation true, and also on the curve true fact. Cool. Yeah, so young carer, let's do that one. Flora started for me, thank you. I think that does sound like something that if your UCAS referee mentioned it, I think that's an important context around, I guess, around how you're studying, how your, I guess, life is, like the context around how you're preparing for university and how you're preparing with your schoolwork as well, I suppose. If it's too late now, then you could, I suppose, write to the college you've applied to at Oxford. If you're asking because you're in year 12 and you're thinking of applying next year, then yeah, it's the sort of thing that I think we'd be interested to know, because lots of people have been asking about this kind of context around applications. We don't just look at your maths score, we're interested in the context of your application too. We get lots of contextual information, some that people declare, some that we get some statistics about people's educational background that helps us make these decisions sort of with more information than just the maths score number. We get more information about who you are from the rest of your UCAS application. We get you to do quite a lot of UCAS applications, quite a lot of information there, but putting it all together means that we don't just make our decisions based on maths. Okay. How are we doing? How is it being considered? Flora started it. I tried to talk about it. There's not a simple answer, right? There's not a simple... yeah, okay, right, good. I've drifted off. What am I doing? I thought I would like to talk about some short questions. Should we do some short questions next? We're about to hit 6 o'clock, and I know some people are going to go at 6 o'clock. Let's talk about I. How was I doing in the poll? How was I doing in the poll? I'll turn the poll back on, but I want to pick the top ranked. 1A has some votes as well. People don't like 1A. Okay, let's do 1A and 1I, and then maybe some more long questions to round things out. I caught people out because it is a geometric series. We've got this geometric series. We want this to be equal to tan x, but in order for us to write down the sum to infinity, we need the common ratio to be between -1 and 1. So that gives us an extra condition there. We need this thing here for this geometric series. We need 1 over tan x to be between -1 and 1 for this sum to make sense. And it's quite annoying that you can go and do the algebra, but if you forget about this, then some of your sums didn't actually work out. I said that quite vaguely, but you can write down formally what the geometric series is, but this thing is only actually the sum to infinity if 1 over tan x is between -1 and 1. So there's this extra condition hanging around, which most people, I think, forgot about because it's too exciting to go and, you know, I don't want to think about conditions. I want to go and solve this quadratic equation. It is a quadratic equation if you multiply top and bottom by tan x and then write u equals tan x and rearrange it, and remember that tan x takes all the values between, but it's a quadratic equation, but then you have to throw away one of the roots because it doesn't satisfy this condition that most people forgot about. So this question was tough. I think the answer is 1, but who knows. Yeah, that fact called out. Lucinda. QI, nice idea, but I lost the mark. There you go. So there's someone in chat. Further maths. Will it be taken into account? Molly had a good time with this question. Cool. Right. We're going to do a couple more just to... We could do some quick fire ones. I saw people talking about 1A. What are people saying about 1A? 1A also confused people at the time as well, I think. So 1A talks about this square with centre 3, 4. And the thing that people drew, I had a look at people's work, because you answer in the booklet, I've got people's actual submissions. People drew all these squares that look like 1, 5. So people drew these squares like this. Like this big square, and then picked up the other point. So there's 1, 3, so 5, 5 over here. So I think surprisingly many people picked B for this really long square. But this is not a square, because this would be, what would this be? It'd be 1, 3 or something. This is not a square because this side length's 2 and this side length's 4. This is a rectangle. The trick is that this square's not lined up with the axes. It's a square and an angle. Let's try and draw that. It's a square like this. It's not lined up with the XY axis. It has to be because this displacement from the centre to over here is not at 45 degrees to the XY axis, because this displacement is, what is that, centre 3, 4 and corner at 1, 5, so it's up 1 and it's left 2. So it's not kind of at 45 degrees like it would be for a lined up square. It's got something else going on. People drew a sketch, it's got a tilted. And some people got a bad sketch, but the correct coordinates, which I like. And someone is drawing attention to, welcome to the Oxford MAT Livestream. Today on the Oxford Maths Livestream, we've got a picture of a rectangle. Hi everyone, this is a rectangle. It feels silly saying it out loud, but people got, I think, quite excited that they sort of cheated the system and found this thing with this 5, 5, the same y coordinate, right? Because it's lined up, which is a shame. People also looked for other points with the same radius. So what is this? This is root 5. People use the fact that the corners of a square are all the same distance away. I think if you do that, you find that this one is also root 5 away. This one, 1, 2, is root 5 away. This one is 1, 2, root 5 away. And this one, 2, 2, is not. So this one's out because it's the wrong distance away or something. But there are 3 others that it could be. They're on the right distance from the centre. Some people got a bit confused between squares and circles, but squares and circles are, well, not really, but some people checked the distance to these points and forgot that not all of those points are corners of the square. I think I threw in a couple of these for extra coordinates. It's a distance preserving transformation, said someone in capitals, which is terrifying flashbacks for me. Cool. It's on a funny angle. Loads of diagrams trying to figure it out. Sorry. Cool. Okay. And I wanted to do 1J. People are leaving. I can see. Bye if you're leaving. Good luck with the mat. You got this. Let's all quickly look at the encouraging statement. Oh, you've got this. There you go. Bye if you're going. Okay, we're going to do 1J. Oh, 1J is fun. It's another question testing whether squares and circles are the same thing. It's observing this fact that if you start with a square and you make this circle bigger inside, then at no point is the circle the same thing as the square. Right. So that's different. Oh yeah, the answer to question 1A was D, I think. 2, 2. It doesn't look like it should be, but it's, I think, one of the corners. Okay. People are going to tell me off for using the phrase centre of a square, aren't they? Good, cool. 2 down and 1 left, which I think is right. Yeah, Trains Nerd has got a thumbs up for that as well. 1J I didn't understand at all. Bye, Millie. I don't think I've got this, says someone in chat. Aww. Matt's not on the word cloud. Yeah, it's weird, that one. I'm going to think of the motivational quotes. Oh, Rose thinks that the centre of a square is morally wrong as a concept. Sorry. I think I said centre of a triangle on 2019 as well. Maybe I'm done asking about the centre of shapes. Regular polygons. Feels like they've got a centre, right? Has a hexagon got a centre? I feel like a hexagon's got a centre. I know where it is. Put a circle through all the corners on there. That one. Right. Good. Okay. Bye everyone who's going. J is nice enough once you've worked out what's going on, I think. Because these regions, it's very complicated. I got into it, I suppose, by thinking about special cases. So thinking about what happens if R is about 0. Maybe this says something about how I like to do problems like this, to think about, you know, the kind of extreme cases. If R is about 0, then I'm going to zoom right in. It's like a tiny little circle. Then the area A that's inside the circle, basically 0, forget about it. But the area B that's inside the square but outside the circle is almost all of it. So B is about 4. So it starts at 4, which is not a helpful observation because all of these graphs start at 4. Okay. Suggestions from other people. Oh yeah, okay, so regular polygons I can have centres for. Okay, good stuff, chat. Yeah, obviously I'm not going to comment on the centre of a kite. Cool. Can we expect, look at this question. Can we expect this same this year? A return to normal difficulty or somewhere in between? It's such an audacious question. I mean, you're asking it from a good place. I like that you're looking at the past questions and thinking, oh, I wonder what's going to happen this year. But obviously I'm not allowed to say. If I'd made this test incredibly difficult, easy, perfectly in the middle, obviously I'm not allowed to tell the live stream that. Sorry. Cool, bye. It was the same person immediately. Bye, gone. Okay. Where was I? So I'd had this idea that B is about 4 if I was really small. Maybe I can flesh that idea out a little bit. If I was a bit bigger, then B A is still 0 because A is the region inside the circle but outside the square. So B is going to be 4 minus, I suppose B is equal to 4 minus pi r squared. Cut out the circle in the middle. Not that, that's inside the circle too, inside both. Which means it curves down, so I think it's not this. This one's curving upwards. It's like an unhappy parabola, 4 minus pi r squared. And then I thought about some big cases, like really huge circles. If you've got a really huge circle, then the answer is, I think, A is pi r squared minus 4, and B is 0, because there's nothing inside the square that's not inside the circle. So then it's going to be some sort of curving up parabola, like these ones, but not like this one. Then I've got to decide, I've got to actually engage with the question really, I've got to think about what's going on in between. Does it come down and miss 0? Does it hit 0? Does it hit 0 sharply? Like some curved bit or sharp bit? Actually this thing is never 0, because these things are both areas, so maybe this is tricksy, but they're areas. The sum can never be 0 unless both of them are 0. But we can't have both of them 0 because even in the in-between cases, sort of in-between cases like this, there's some areas that are inside or outside one or the other. Squares and circles aren't the same thing, so we can't have both of these shapes perfectly matching up. So this, when I say it, it sounds stupid, but it's actually quite a hard idea to have, which I think is why it's numbered J towards the end of the multiple choice, at the end of the multiple choice. Final tips on math, it's going to be fine, you got this. It's a maths test. You love maths. Right. Is math more important than predicted grades? Yes, for Oxford admissions. Because, well, hang on. So almost all of our applicants have the same predicted grades or have great predicted grades. So it's not helpful for us choosing who we're going to shortlist. So it's more important to us because we can actually use the math to decide, well, help us decide who we're going to shortlist. Yeah. Whereas predicted grades, everyone's predicted for A-levels, everyone's predicted A star for maths, A star for further maths. Unless there's some reason why they're not doing further maths or some sort of special cases going on, but it's not actually helpful for choosing between our applicants. We're very lucky that we've got all these applicants who are very keen on maths. And I'm very grateful to you for watching as well. Cool. Number of viewers has gone up. I don't really know how that happens. Hi, if you're watching this. If YouTube's promoted this to you as like a thing to do with your evening, then hi, my name's James. I'm doing maths questions from a test that I used for maths submissions at Oxford last year. Thanks for joining in. Cool. There's live chat going on. We're not using YouTube chat, we're using Slido chat. And we're going to do this for another half an hour or so, maybe. Live chat has got voting on which questions we're going to talk about. I'm going to do something weird. I'm going to reset the voting. Let's see what that changes. Oh my word, look at that. Oh, did you see them all go down? Oh, I love the way that the Slido chat's animated. It's quite pleasing to me. Right, I need to take out 1A because we talked about it. Take out 1I and J because we talked about them. Did we talk about 3? We talked about 3 as well. I'm going to see what else is going on. Question 5 is currently doing well. Question 5 is one of the questions that everyone attempts. It's for everyone. Question 7 was doing well for a moment there. 6 and 7 are computer science questions for the computer scientists. Why did I join Oxford after studying in Cambridge? Now that's exciting to me because somebody's replied. Flora's answered. Thank you, Flora. Yeah. Silly answer because it's obviously better. Realistic answer. They offered me a job. Right. Cool. I applied for a job. Why don't I use YouTube live chat? We think that Slido chat is less spammy. We think Slido chat's a little bit better. It supports replies, and you can do it anonymously without a Google account. So Slido has these like nice features about replies and anonymous questions. Also, we can moderate it a little bit better. What's more important in the selection process, math or interview? So when we're selecting people for interview to decide who to shortlist down for interview, we don't have interview scores, so we have math scores that help us do that. Then afterwards, we look at both. The interviews are obviously important. We do still have data from your math test and from your application. We look at it all together. We look at everything. We love data. We've got loads of information. We're not just going to look at the interviews because we've got all the rest of this information about you. Stuff on paper, stuff on your mat. Look at it all together. And we have massive arguments about who we're going to make offers to. Actual humans talking about who we're going to make offers to. We don't give it to a computer. We don't put it in a black box and say, oh, okay, calculate that for us. Just we're going to go for lunch now. Let us know who we're making the offers to. We have massive arguments about who we're going to make the offers to. We have a big meeting at the end where we get people together from all the colleges, and we have massive arguments about who we're going to make the last few offers to. Oh gosh, someone's asked what my favourite chocolate is. I don't prepare these. I was ready for the duck question. Oh gosh. I think I'll eat anything, right? I'll eat any of them. Right. Oh yeah. Okay. Right. Cool. That was a weird answer. Boo statistics. What's wrong with statistics? What's the bribe threshold for offers this year? Wow. I shouldn't even joke. I think I'm not even allowed to joke. Right. Cool. Right, good. How are we doing? We've got a poll going, haven't we? Or did we have a poll going and then I forgot to look at what the poll ended on? Should I turn off the poll at one point? Question 4 was doing well in the poll. I thought we were going to talk about question 4 at some point, weren't we? Question 4 is doing well, and then 5, 6, 7. Okay. That's... do the questions in order, James. How would you put an elephant in the fridge? I would take the butter out first. I've heard that joke before. Take the butter out first before you put the elephant in. Okay, do we ask more maths questions or more questions on our personal statement? That sounds important. We're going to ask more maths questions. It's our chance to do some maths live with you. Us asking maths questions, you saying, I'm sorry, I don't understand, and us saying, that's okay, let's change the question a bit, and actually a set means a collection of things. And then you say, oh, I see, a collection of things, and we do the question. And then we make it a little bit harder, or we change something and ask a follow-up question. You say, no, I've got this now. A set is a collection of things, and then there are twice as many. And we go, wow, that was quick and amazing. Why did you treat dy by dx as a fraction sometimes? This is like a separate rant that I should do at some point. Dy by dx is secretly a matrix. Dy by dx is secretly a matrix, and when you want dx by dy, what you're actually doing is finding a matrix inverse. But because matrices with one element in work like numbers, you just turn the number upside down. But secretly you're finding a matrix inverse. I should not do this rant now, we've got other things to do. What course did you get a degree in? I did a maths degree, trains nerd. I did a maths degree, then a maths masters, then a maths PhD. The PhD is why I've put... there it is. There it is. Cool. Yeah, so in higher dimensions, if you've got more functions and you're taking derivatives with respect to more different letters, then you actually need to engage with the fact that the derivatives work like a matrix. And if you want to turn them upside down, you need to work out the matrix inverse. Some people don't know about matrices yet. You're in for a real treat when you learn about matrices, which you will learn about matrices at some point. They help you do things with derivatives too. Cool. First year maths. Why did I never tell you this? Because it feels really silly to tell people that, I'm taking a thing you understand, numbers, and I'm telling you that number there, that's secretly a 1x1 matrix. Feels really silly. Cool. Forgot to do part 1b. Yeah, there's loads of subparts on this one. We printed this question with a typo. Sorry everyone who did it. Really sorry for any inconvenience or stress or panic or confusion. We put too many minus signs in the help text at the top, which is annoying. We put an extra minus sign here. I fixed it on screen, but yeah, it was not good. We ended up giving sort of marks to people who'd been confused by the minus signs, even though maths that they were writing was sort of weird and different from what was expected, because they were confused by the extra minus signs, which is on us. Okay, happens sometimes. Good. Okay. How do you prove that A of BC equals C of BA? I think it's not. I think those are different things. That was easy. Right, cool. What are we doing? Flora's off. Bye, Flora. Hang on, I'm just saying bye to Flora. Thank you, Flora. Right, it's just me driving chat now. Here we go. Matrices being something to do with derivatives. We'll do that. Okay, we'll do a bonus thing. No, okay. You need to know about partial differentiation for that to actually. I sort of hate this as well, that there's things that I say, right? So I say derivatives are sort of secretly matrices, but there's so much in between maths for that to mean anything that when I say it sort of doesn't mean anything unless I also tell you all the in between maths, which I really don't have time to do. I need to not get distracted and talk about question 4. But I already recorded a video for question 4. Right, there's a video for question 4. We're going to talk about derivatives. It's the last one before that. Let's just chill a little bit. This is not math. Let's label that in case somebody takes like a screenshot or something. Derivatives work a little bit like matrices. Here's the thing that I want to show you. When you come to university on a maths course, we tell you about functions that instead of, so here's my like normal functions. You put a number in and you get a number out. At university, we would like to think about functions where you put a vector in, and so my function, applies to that vector, and I get a vector out. Oh, wow, okay, so because we like vectors, we like functions, can we have a function where we put vectors in and get vectors out? This is a pretty complicated thing, right? Because any vector I put in, I'm going to get a vector out. Maybe it's the same vector, maybe it's a different vector, and there's some complicated rule about what vector I get out. There's things you can do here to talk about, well, normally I do a derivative, right? I do dy by dx. Here, the things that I might be interested in is I might be interested in things like how does u depend on x and y? So those are kind of two different questions. How does v depend on x and y? So as you change x and y, u and v these components might be completely different things. And they might change in different ways. So there are kind of these different derivatives you could work out to talk about how does u change when I change x? How does v change when I change x or y? There are 4 different objects you could work out. The change in u with respect to x, the change in u with respect to y, the change in v with respect to x, and the change in v with respect to y. And for historical reasons really that I don't want to talk about at all, you write these ones with these curly shapes d's instead of normal letter d's, but they're just derivatives. They mean how does u change when I change x if I keep y the same, and how does u change when I change y. Here's the fun thing. If you can invert the function, then the things you might want to ask about. So if you can invert this function, then you might want to talk about how does x depend on u, how does x depend on v, how does y depend on u, and how does y depend on v. And the big surprise, maybe too much, is that this matrix is the inverse of this matrix for the inverse function. which is really cool. So when you want to work out these derivatives, they're just the inverse of those ones going in the other direction. If you're in 1D, if you're in just one function, so you've just got this u just as a function of x, then your matrices are just these top left numbers. So the inverse is just the inverse of, well, the inverse of a 1 by 1 matrix is just the inverse of that number. So that's what I'm talking about. This kind of higher dimensional thing works a bit like matrices for when you're dealing with functions of vectors. And the one-dimensional version that you do in school is just like having 1 by 1 matrices, and the theory matches up. Kind of not quite just turning a fraction upside down, because these things are not quite fractions. Okay, I can't stress enough how much that is not maths. I think you earned it. It's been like 12 weeks of doing just math questions. We needed some other maths at some point, right? Let's do some questions from chat. If one person had medium marks in 84% is not medium, 84% is pretty good. And can they select a person who scored about 70 in that? Yeah, tutors can select anyone for interview. They can do it based on anything. It's recommended that they look at math scores, but that's not the only thing. Okay. Cool. So some people have seen partial differentiation in a Tom Rocks maths video or in OCR additional maths. Someone says, why are your V's so weird? My V's are not weird. My V's look like this. That's normal. I'm trying really hard to make them look different from U's. That's it. I do my V's like that and my U's like that because I used to do everything like, I can't even do it wrong anymore. I used to do everything like that, and then those look too similar. So I'm making them look very different. That's why my V's look like that. I guess that does look a bit like R, doesn't it? Oops. Okay, right, cool. It's not that weird. It's not that weird. There was an OOMC on partial derivatives. We did more detail on that topic for about an hour. I can't remember. Did I do that? I think I did some of that. We talked about partial derivatives, those things, the D shapes. We talked about that kind of idea of taking the change of some output variable with respect to one of your many input variables. We talked about those independent changes in some episode of OOMC. Someone would like question 7. People have enjoyed the break. B says, what are we doing next week? Next week is the day after MAT. I thought we'd do a live stream where we don't talk about MAT at all, and maybe talk about other maths. Like that. I want to talk about not maths. So doing maybe some university maths or maybe just some maths that I think is neat. I've got one plan. I'm going to make a second plan as well for other stuff to talk about next week. Peter says thanks. I'm saying happy birthday. Bye if you're off. Becca likes that. Oh, the derivative's like a linear operator, says SV. There's some technical language there. It's a bit linear like linear algebra. It's matrices. Okay, right. Vector space. Oh. All functions. Cool. People are going to do extracurriculars. Do you want the Oxford statement on extracurriculars? Sounds helpful. Oxford doesn't consider irrelevant extracurricular activities when we're looking at applications. So for maths, that means things that are not related to mathematics, we just don't consider them. If you say that, I can kind of tell most people's personal statements don't stress about this. Most people's personal statements end with like a paragraph or so about how they're great at karate and also they do some swimming. And that's not a selection criteria for maths at Oxford. We've got so much maths stuff that we can make our decisions based on. We just want the people who are going to do well on our course, which doesn't involve any karate or swimming. Maybe it should. It should not. Okay. Complex numbers are not on MAT. Has been established. Done a complex numbers episode. So many complex numbers on the Maths Club. Maths Club's coming back in January. If you missed out on the Maths Club this year, it was all recorded, so it's on this YouTube channel somewhere, Maths Club stuff, and we're launching it again in January. I'm really excited. We're going to talk about 20 more maths topics, maybe with some repeats, but 20 more maths episodes talking about stuff together. Cool. I've slowed down quite a lot, haven't I? You've noticed that some people with low maths scores got an interview. We looked at the rest of their application. And there are some cases, I don't want to go into details, but there are some cases where there's a good reason why somebody didn't have a sort of competitive maths score compared to everyone else, but we still wanted to interview them. Okay, we're allowed to do that. It's not a hard cut-off. We're allowed to look down and say, we feel sorry for you, we're going to interview you. Cool. I have 83% in a higher secondary exam. Can I score more than 70? I will have a place. Well, we're going to look at everything together. And there's no algorithm. I can't do some maths on those numbers. I have to look at everyone else and make a decision. Right, cool. Where's the video on question 4? So on this YouTube channel, if you go to videos or uploads or scroll down to all MAT playlist, we uploaded it about 2 hours ago. I hope it's up. I hope it's visible. There's this video. It's not just on question 4. It's on every MAT question on 2020. It's about 2 hours long, but it's got timestamps that you can skip to question 4. Right, cool. Am I going to do question 4 now? Are there error carried forwards marks? There are error carried forward marks. Yes, if you do something wrong, then sometimes we can still give you marks later on. Cool. Is OMC coming back? I guess next week is going to be a little bit it's secret. Next week's going to be a little bit like OMC. Feeling very... Yeah, season 3. Is it 3? I've lost count a bit. Is this season 3? At some point I told people this was season 3, and then we gave it a different name, so this doesn't really feel like season 3 at all, does it? Feels like Math Club. Season 3, January. Oh, it rhymes as well. What is the online maths club? Yeah, so you can find it if you go to the page down there, but instead of typing Mat Live, if you type club, C-L-U-B, is my short URL for the maths club. It was a live stream like this, but we talked about not math, just other maths that we were interested in. We got lots of students involved to turn up and tell you about some maths. There are 26 episodes from earlier this year on the website, /r/club, and there's going to be some more starting in January. You don't have to watch the previous ones. There's not going to be a test, and we know that most people aren't going to watch the previous ones. Cool. Final advice, it's going to be alright. Watch this video. Oh, I love it when people have linked a mysterious YouTube video. Let's have a look. Oh, it's actually Matt 2020 all questions. Thank you. There you go. Visible to me, says an anonymous person. And there's a link. It's about 2 hours. A little bit less. I think I've talked faster this year. Favourite equation, favourite maths question. Questions 4 and 5. Right, cool. People want to do some maths. We're going to do some maths. We're going to speedrun questions 4, 5. Talk about the ideas. Details in that 2-hour video that someone's kindly linked to. And it's also on this YouTube channel if you're watching the replay. Is anyone still here? People are still here, my word. Cool. People want complex numbers next week. This is not a different Slido, right? Different Slido, different thing. Someone sent me a meme. Someone sent me a meme by email. It was the Spider-Man pointing at another Spider-Man. And one of the Spider-Mans was labelled Oxford Online Maths Club. And the other one was labelled Oxford MAT Livestream. Spider-Man. Which is very good. Thank you for sending me that meme. Cool. So, symmetries of these functions. Symmetries means thinking about transformations of graphs. Even functions have this reflection symmetry in the x equals 0 line. I was going to write x-axis and changed my mind. The y-axis. Odd functions are supposed to have this rotation by 180 degrees. Ooh, 180 degrees about the origin symmetry. Or you could think of that as being two reflections. One to put the minus sign here and one to put the minus sign here. Flipping the x-axis and in the y-axis. Okay. B, yes, you can request topics, I think. There's an email address on the club page if you want to suggest things. You don't need to suggest complex numbers. We already know you love complex numbers, everyone. Is it happening next year? Yes. Okay. I'm a bit behind the chat. Like 1 minute. What is happening next week? I'm just going to talk about maths. It's going to be the same thing, but without math questions on the screen. Can you imagine that? Just other maths. I've been spending 10 weeks where I'm only allowed to talk about the first half of A-level single maths. There's other maths that we would like to talk about. You know, after the math, we're allowed to think about other maths again. Right, cool, good. What's the hardest topic in mathematics? Personally, I found analysis very difficult, but sort of think it might be number theory. Number theory is definitely the hardest easy. Number theory questions are definitely the hardest easy questions. Easy, hard questions. Hard, easy questions. Questions that look easy but are actually really hard. Cool, people really want those computer science questions. Okay, we're going to start speed running it. Cool. Forget chat for a little bit. Let's go. The speed run, the 10-minute speed run is on the main YouTube channel. 2-hour long version is on this YouTube channel, and some sort of messy live version is happening now. Right, derivatives of the functions. We wanted you to think about reflecting or rotating the tangent line which is kind of a weird idea. You have this function like this, and then that's not quite good. That's not quite good enough. There we go. To take this tangent line and think about what happens when you reflect it. When you reflect it, you get the opposite gradient. You get a minus sign in the gradient. So you can use that to explain what's going on for the derivative of an even function without actually differentiating. So this general thing talking about the things. People are still being nice in chat, which is nice. Put your answer in words is fine for show that questions. Is it better to mention contextual information? Mentioning stuff is always good. It's helpful. It's one of the reasons I like personal statements is they mention useful information, as well as talking about karate and swimming or whatever, which I don't use. Okay, cool. So a few marks here for talking about reflecting tangents or rotating tangents. People found that part of the question extremely difficult, I think, so not terribly helpful for distinguishing between applicants. Also because we had too many minus signs, so the functions we asked you about had lots of different symmetries as well as that one, so it's all a bit of a mess. But second part, separate, kind of okay. This is my favourite question. I love this. Is James related to Marilyn Monroe? Has it appeared on chat yet? Here it comes. Right, okay. Marilyn Monroe is not her real name. Do you know who she's named after? She took it as a stage name. She's named after James Monroe. James Monroe, the 5th American president. But I quite like the fact that people think I'm named after Marilyn Monroe. No. She's named after James Monroe. Right, cool. Right, we're going to talk about this triangle. We're going to talk about the triangle. The idea for this one, arguing geometrically, is not something we say very often, but we wanted you to sort of think about geometry and shapes and give us some explanation about why these things add up. So I guess you need a picture with negative theta, like this, and some sort of idea about labelling this bit matching up with this bit over here. And those areas added up to 1/2. There you go. Because there's some congruent triangles going on and the area of the overall triangle is 1/2. So quite nice. Then we're actually asked to find this formula for A of theta, which means how big are triangles. Thinking about the biggest triangle, think about how big triangles are is one of my favourite things using MAT level mathematics. I started at one point a novelty Twitter account that was just about big triangles. Anyway, how big are triangles? You know loads of rules about how big triangles are, so you'll be okay with this bit. And sketching a graph of that. So it starts at 0 when theta is minus 45, and then it increases as that goes up. It goes through here, then it increases. It takes up some value, like 1/2 up here. I think it's about a quarter in the middle. This is 45 degrees. This is minus 45 degrees. Not too bad, right? So it's kind of first part of the question is kind of separate and weird. Last part of the question, a bit different. Anyway, thinking about part 2a, the symmetries of odd and even functions, tell me about the symmetries of this graph. So part 2a was the symmetries of odd and even functions. And this one, it doesn't look like an even function because it doesn't go back up again for the same values on the negative side. It looks a bit like an odd function. It's not quite an odd function. All its values are positive, so it doesn't do this opposite side is negative at the same side. But if you translate it down a bit, if you bring it down, that thing is an odd function. Which you can prove with this rule. This rule is not quite the rule about being an odd function, but if you do a translation, then you end up with something that goes through the origin and is an odd function. So then you can see it's got rotational symmetry, so this thing's got rotational symmetry around this middle point here. Okay, and then because there's an odd function involved, if you differentiate it, you get an even function, and then you differentiate it again, you get an odd function. And odd functions are always 0 at 0, because so odd functions have f of minus x is equal to minus f of x for all x, including x equals 0, at which point they say f of 0 is equal to minus f of 0. That means f of 0 is 0, which is the thing that's going on here. The second derivative is odd again. Polynomials, yes, okay. I can't remember how many marks we gave this argument. People telling me about polynomials in chat. Problem is, we're not just talking about polynomials. I'm not just talking about polynomials for these functions. I think we were generous to people who told us about polynomials. Yeah. Does it always work? It definitely works for polynomials. But then what about things that are not polynomials? Turns out that if you know some very advanced mathematics, then that's kind of good enough, because you can approximate some things with polynomials, but getting complicated. I think maybe we didn't give this. Maybe we didn't give this very many marks, because most things are not polynomials. Tough. Okay. Yes, Lily's right. There we go. Sorry, chat. Rotation about 0.25 by 180 degrees. Good. And I like, Lily, I like the way you've specified the point as well as the amount you rotate it by. Because you need to say both, right? For rotational symmetries, you need to say which point you're keeping still and how much you're rotating. For reflections, you need to say which line you're reflecting in. But look, Lily's given me a point and an angle. Because it's 180 degrees, you don't have to say clockwise or anti-clockwise. If it wasn't 180 degrees, then I think I'd like it if you said clockwise or anti-clockwise. I've just realised I'm trying to demonstrate clockwise or anti-clockwise in a mirror. No, it's not a mirror, so I need to... Which way do clocks go? Not that way. Clockwise. Ha! There we go. Maybe that made sense from home. Or maybe you're imagining being me, in which case... Oh, right, never mind. This is my first time watching your live stream, says someone. You've joined at an embarrassing moment for me. I can't remember how clocks work. It's 6:30, he says, checking a clock that's not an analog clock. Do I recommend watching all of your live stream videos? No, there's too many of them, they're too long. That would take a long time. Maybe just look at some past papers. Maybe look at some recent ones. Check your answers, if you like, using the solutions. Sometimes the solutions on the MAT page are quite short, and you want to see how did anyone think of this, how would you explain this in more words. The video solutions that we've been making, they're about 2 hours long in total. They're a bit longer and have more working out and thinking. There's these videos on this channel with me trying to think about the questions and get to the answer a little bit more slowly than the solutions we put on the web. And there's also some 10-minute videos around if you want a very quick look at the answers with no thinking. Cool. Bad predicted grade. Math teacher does not like me. Sorry to hear that. Score well in the MAT. I think scoring well in the MAT is more interesting than predicted grades. We know that predicted grades are not always true. We would need to think that you were going to get the... I suppose we would be a bit worried that you weren't going to make the grades, but if it comes to it, we can make you... the way we make offers is we make conditional offers. We make an offer in January and we say, you've got until the end of the school year to get these grades. We've got some standards about what we're looking for. And we can make that, if we're not sure, we can do that, and then if you make the grades, then that's fine, you get to start the course. If not, then you don't make the offer. Okay, so maybe it doesn't matter too much, but we would like it if you made the grades, obviously. Cool, right. When are the 2021 solutions out? The day after the MAT. So MAT, when you take it, is under embargo. No one's allowed to talk about it for 24 hours. And then the next day, on the 4th of November, I post the test paper and the short solutions and a 10-minute video, MAT in 10 minutes. That all goes up the day afterwards. You get some solutions. But let's do it straight away, just so that if you're stressed and you want to check your answers quickly, then there's some way to quickly check your answers. Cool, okay. If you invoked Taylor's theorem, then it got very complicated very quickly, because Taylor's theorem is quite complicated. Not everything has a Taylor expansion, but we don't really think you know that. So, well, it's hard, right? Do you want to talk about radius of convergence? Not really. Not really, I think. What's the actual question? Is the polynomial good enough for infinitely differentiable functions? I'm worried that it's only good enough inside the radius of convergence, and now I'm really worried that we're talking about radius of convergence. Analysis, hey. Good. You want a Christmas episode? Christmassy maths. Yeah, and I'm sort of with Patrick and Becca. Oh no, Patrick says, but Patrick wants it immediately. Becca's like, why would you do that? When I was a student, I'm sort of with Becca. I do the exam, try to forget about it. I don't want to know if I got the answers right. I don't want to know what the questions were anymore. I want to forget about it. So I'm in this weird position where every year now I make a 10-minute video that I wouldn't watch. So fun. What's your job like? I produce content that I don't want to consume. One of those days. Right, okay, we're going to talk about question 7 a little bit. Question 7 involves writing down these rows of tiles. Hi, maths students. Question 7 is not one of the ones that you'll have to do if you're a maths student, but anyway, we're going to look at it because it's quite systematic and cool, and it secretly involves some simultaneous equations, so watch out for those. There's lots of reading to do, which I'll let you do now. There's always this A and a B as kind of placeholders, and there's some C's in between and on either side. Some other stuff going on by anonymous person. And you join these together. When you join them together, you get more C's. You put together all the C's that you had from the previous things in each place. You can join together any 2 rows that you already had. They don't get used up, they still exist. And you're allowed to join something to itself, which is a little bit weird, but really just means sort of taking that one and doubling the number of C's in each position. Do I have examples of interview questions? If you check the Mat Live page, you'll see after Mat, so we're doing one session on not talking about maths, doing some other maths because I want to. We're doing a session on Mat 2021 debrief, and then on the 18th of November we're doing a live stream where we talk about interview questions. I'll have some interview questions on screen, and we will talk about what happens in interviews, maths questions, and we will do some of the questions that you might do in an interview, maths questions. We will do some maths. Interview questions. It's going to be fun. It's going to be a bit like this, but with interview questions, if you can imagine it. Some people say that I've only got one idea for what maths content looks like, and it involves me in a square in a corner and different sorts of maths on screen, and that's a very fair criticism. Right, cool. People who are not going to watch my video, thanks. Last year's one got about 250,000 views, which is... Anyway, right, cool. Enough chatting about views. Let's do some maths. 2 examples of rows that you can make in the game. So let's practice doing some joins together. I'm going to join this row to itself. So joining it to itself means that I get an A and a B, and in between I get all of the C's from the first thing I'm joining and all of the C's from the other thing I'm joining in the middle. Over here I do something similar. I get all of the C's from one thing I'm joining and all of the C's from the other thing. So I can make this by joining together the first row with itself. A different thing that I can make is I can join these 2 rows together. So I'll get 3 C's at the front, 1, 2, 3. I'll get 2 C's in the middle, and I'll get 1, 2, 3, 4, 5 C's over there. Cool. People have had time to read the question now. Craft a penguin. Oh my word. What do you do before maths? Drink coffee or meditate? Listen to Mozart? You can do whatever you like that calms you down and makes you happy. The suggestions from my experience. Don't ask me. I'm a very stressed person. Very nervous. Did not work out a good strategy for not being nervous about exams. Not the right person to ask. Right, let's ignore that one. We're not doing that one because I'm not a professor. Cool. Struggle. On my website it says that Cambridge University creates the maths papers. I suppose they physically create the physical math papers. I create the content or help coordinate the making of the content. Anyway, part 2 is really interesting for this question. It's quite creative. They ask you to come up with rows that you can't make in this game by joining things together. Can I have suggestions in chat, please? Time for you to join in. What rows can you not make? And we're looking for an explanation of why you can't make them as well. But let's go for the ones. Anika is gone. Bye. Bye to the user with the username Grant Sanderson. Am I doing interviews? I think I might be. Yes. Not everything has. Yeah, I could try other shapes. Empty row. Okay, right. I like empty row. Looks good. Except the rule for part 2 is unfortunately we need to have an A. I think they saw this coming and they want you to have an A and a B in there. Yeah, here we go. Zach's still here, good, and an anonymous person. A and B can't be together, so we can't have something like this because you can't get rid of the C's in between. When you join things, you only get more C's, so you can't have no C's. And Zach says this is not possible. So it's a slightly different idea because it only has one C. It's sort of smaller. The rows get bigger when you join them together, and this is smaller than even the smallest rows we've got. Good stuff, Zach. You can't have A, B. Yeah, I agree. Oh, there we go. Chat, look at chat go. There's great. There's C, A, B, C. I've got that one. George says you can't remove C's like Zach. Yep. Is an infinite row a valid answer? Interesting. I can't remember I don't know if we would give that a mark. Yeah, fine. Why not? We haven't defined what a row is. So you want infinitely many C's. You don't need infinitely many C's, but where's the infinitely many C's person? Here we are, infinite rows. I feel like benefit of the doubt, I might give that a mark. It's quite cheeky because you just definitely can't make infinite things. Is an infinite row even an example of a row? It's a bit disputable, but I think I'll allow it for now. Cool. Yeah, so Becca's got a point here, which we're aware of. The actual process of sitting and doing an exam, for most of you it's your first actual exam ever. So maybe that question about Mozart and coffee was like a chance to do relevant advice. You're going to be in a slightly unusual place, probably, like some different room that you go to do an exam. So if you find new places unfamiliar, then try to maybe find out where it is and find out what it's like. When I go to new places, I like to look in every direction and find out what's around me. Luckily for me, my exams were in the room where school assemblies were, so I'd already looked at everything. You're going to be in maybe a different room, maybe that you haven't been in before, and you're going to be given hopefully some sort of table space, not very many distractions, and a copy of my test paper. It's got a bit for you to write a number on the front. You can look at past ones to see what the front looks like, so you'll be looking at that for quite a bit, and then someone with a clock is going to say go, and it's time to open it. First question is on the left at the top. Oh no, that's where the grid is. That's where the answer grid is. First question is on the right at the top, 1A. There's some maths questions. I think once you get to that point, the person said go and you've opened it and you're looking at the questions, you'll be all right because now it's maths. There's always admin of you've got to sit down and you've got to not have any calculators, you've got to not have any distractions. But then actually doing maths without any distractions, it's actually, I hope, not too bad. There's some time management stuff in there as well, but if you're just doing stuff, then if you're doing stuff, then I can't ask anything more, right? Achieving maths. Yeah, thank you, Grant. Cool. Is the day of Matt exciting or stressful for me? Do people want to take a guess? The day of Matt is the most stressful day of my year. People in Oxford dancing. Right, okay, drinking and deriving. Hey! Cool. We had some good suggestions of things that you can't make. There's another one. 7AC 23. You can't make just AB. Good. Have I checked for typos this year? Haha, thank you. Yes, I have checked for typos this year. Can you imagine? Right. Yeah, thanks, Wheeler. Okay, right. Let's keep going. It's a game for a single player, right? It says someone pulled this out. It's really stretching what it means for game, right? I mean, you have an aim, you're trying to get there, but it's, I guess, like Minecraft. You play on your own and you're trying to create something. Down with the kids, mention Minecraft. Some things go between generations, right? Okay, part 3. Can you make this one? It turns out yes. And here's how. So you can just make this one. It's quite a lot of work. The C48 in the middle, this looks a bit like chemistry, doesn't it? The C48 in the middle is a clue that you need to join together essentially 48 of the basic rows. You know, when you join them, you end up with more C's in the middle. This 48 is kind of a characteristic of having 48 basic rows. If you think about what the basic rows need to be in order to get the right number of things out here, how many of each basic row do you want, then you can come up with a strategy to get the right number of basic rows. And then your plan could be to just join them on one at a time, take those basic rows and join them all together onto this target thing that gradually builds up towards being the goal row. Which is quite inefficient because you're each time just like, forget about everything except basic rows and what I was just doing. And now forget about the previous thing and bring in another basic row. Okay. Yeah, cool. All right, people are now trying to find out how stressed I am. Cool. You can't make BA. Yes, Zach, you're right. You can't make BA. Good. Okay. You can't get the B to the left of the A. So your two examples could be two examples like BA and BAC. Ha 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 ha. Both have B to the left of A. I win. You don't have to give different reasons for your two different things. Kind of fun. Right. Cool. This one you can make. IV you cannot make. This one. It turns out this is too many C's over here, 176. There's too many. Again, there's this 48 in the middle, which means we're joining together essentially 48 basic rows. It's not quite, because we could be joining together other things. It's a little bit more subtle. We could be joining together not quite basic rows, but things made out of basic rows. But I suppose a bit like chemistry, of things being made up of those kind of building block atoms. When you join things together, you're just adding together how many C's there are. So that came from having some basic rows at some point that have been joined together. So if you keep track of how many basic rows were used in each thing you've got, then you can't end up at some sort of illegal combination with too many C's over here, because you can't make that out of basic rows stuck together. Okay. Good. That one spells my name wrong, so that's moderated out. Cool. Part 5. This one's quite good because the solution we put on the web looks really complicated and mad, and how would anyone ever think about it? I think I've managed to come up with a way that's a bit better, and I want to show you this algebra that I promised you. Okay, so C to the 31, 31 C's, A, 16 C's, B, 47 C's. How do you make that? Well, my first plan is to use just sort of basic rows. I've got this basic row like this, and I've got a basic row like this. What's the other one like? What's the other basic row? 2, 1, 3. So my plan is to join together sort of M of these and N of these. So that's my plan, joining basic rows together. It's going to be slow to start off with, but we're going to try to make it more efficient. If I join M of these together, then I end up with C to the M, something like this. And if I join N of these ones together, when I say join N of them together, I guess I mean join and then join again and again and again. Yeah, Zach's got some inequalities for part 4. Thank you, Zach. I think that's correct. Yeah. Or part 5. Ooh. Only just be done. Ah, I see what you're doing. Okay, right, cool. Gives you a clue about how to get in there. Okay, cool. So when I join these together, not 2 here. There we go. N of these together, I'll get N C's in the middle. Cool, okay. So I've got these things, and then if I maybe join these together, I can make this kind of combination thing. Can you see where the algebra is coming in? Yes, you can. The algebra has arrived because I kind of want these powers, this how many C's I've got, to match up with these numbers. So now we've got some simultaneous equations. I've written my N's and M's inconsistently. There we go. Personally thought my V's were weird. Is it the handwriting? Is it the technology? Is it Maybelline? So this N is going to be 15. M is going to be 16. I think. Yes. Oh, 1. M is 1. To make these equations work. And that actually works in all 3 equations, so that's nice. 2, 47, 3, 2, 47. Cool. Piecing all that together, I want 15 of these and just 1 of those. Now, if I do it slowly, I'll do 15 join moves, which is the answer for the last part, 15 join moves. But I can make it quicker by, instead of joining these on one at a time, I can build powers of 2. I can use some sort of binary idea again. Use some sort of binary to shortcut this by building powers of 2, and then instead of forgetting about them and building more numbers, to join those together. Turns out to be some nice efficient way to make 15 copies of this one. 15 copies. My plan is to join it to itself to make c squared, join that to itself to make c to the 4, join that to itself to make c to the 8, and then I've got c to the 1, 2, 4 and 8. I want to join all of those together to make c to 15. Can't actually join 4 things all at once. I need to do it as 3 joins, but that's my plan, to make c to the 15 in the middle, and then stick on one of the other basic rows. Final 7th join to make c to the 16 in the middle. Very difficult question to decide what's the fastest way to do this in general, which is not obvious. It's a sort of properly difficult computer science question, I think. What's the best algorithm in general for making goal rows that you can make? If you want some complicated combination of squaring some number in binary over there, some other number in binary for how many of each basic row you want, what's an efficient way to construct those different powers of C in the middle? Cool, okay, Dirichlet looks at this. Having done this paper last year, it's nice-ish. I had to think about the algebra of it, of how many basic rows I was using. I guess because I think about only using basic rows, because I'm sort of convinced myself that everything's sort of made of basic rows, you know. If I see something, I can kind of tell how many basic rows went into its construction. I could keep track of that along with all my joins. Kind of this atomic structure thing going on. Nice, right, cool, okay. We're getting up to the end now, so I think I'm not going to do another one. These mathematician usernames are fun, aren't they? 3-part masterpiece about Matt on my trombone. Great fun. Right. Matt results released. Right, let's do a few of these start questions, and I will also type answers afterwards. Matt results are released if you apply to Oxford, you get an automatic email in January with your results. That's true. The interviews are conducted in December. Oxford get your Matt score straight away. The Matt is marked in Oxford by Oxford people. We get your marks in our internal databases straight away, and we use them in November to decide who we're going to invite to interview. Interviews offered based upon Matt, yes. If we don't get an interview, does it mean a low Matt mark? Sometimes. It's not as straightforward or as simple as that, because we've got lots of other information to look at. We don't just cut off on that. But yeah, we get the results ages before. Well, we get the results almost straight away as soon as we've marked the thing. Right, cool. Bye, Rose. Okay, I'm going to wrap up in about 5 minutes if I do a little bit more Q&A chat. Oh, I quite like question 7 actually. The solution for this bit, building this thing, just looks, when you write it down, it looks mad. Like, how did anyone think of this? I think I can work out how you sort of build things with binary. We didn't talk about this lovely question. Didn't talk about this lovely question about Santa sharing out tennis balls for children, which has quite a nice answer, and it's a recursion question, which we found out earlier, not popular on this live stream. And we didn't talk about this lovely question about sharing out sweets, which just proves this lovely fact. The whole question is this proof of a nice fact about two things being equal. We talked about 4, 3 and 2 very briefly. We didn't talk about some multiple choice questions. There were some nice ones in here that aren't too bad, that I guess people didn't need to talk about. Some integrals for you to do, some classic, absolute classic maximum value of this trigonometry thing. You don't need to know how to differentiate this. Other stuff going on. Is it worth mentioning that if my teachers were not able to help for math preparation, since they only specialise in the curriculum and some of mentoring in school, we're aware that people's school matters a bit in terms of how much support you get, especially during pandemic times. We take that into consideration. We get, if you're in the UK, we get some statistics about your school, we get some information there. Sometimes people's teacher references, UCAS references, are useful for giving us some contextual information about what sort of support you get from your school. What's the context around your school? You can mention it in your personal statement if you like, I suppose. Might look a bit like your... you can tell us in your personal statement if you like. That's just true. Cool. 1C, 1D. How do you do this one on the screen? Since you ask, I would change the cos squared to a sine squared, and now it's secretly a quadratic in sine x. So up to some worrying about what the value of sine x could be between -1 and 1. This is a bit like being asked for the largest value that could be achieved by this quadratic. It's an unhappy quadratic because of this -3. It looks like this. Can you find out what the maximum value of that quadratic is? And then also check that sine x can do that. Turns out that we want sine x to be 1/3 for this maximum value, which it can do. That's a value it takes. At that point, the value is something like 13/3. So it's just a secret quadratic thing. Was this an easy map paper due to high averages or people being really smart? No way for me to know. Hidden squares. Are computer science questions hardest? Difficult to know because different people do the computer science questions. Nobody does all of them. They're different. And computer science applicants are different. When do you invite people for interviews? We invite people in late December, very late November or very early December for interviews that are in this year. The week that starts about the 13th of December, I think, is when interviews are for maths. So we invite about a week or two before that. You get an email either way. So if you don't hear from us, you will hear from us at some point. Aha! Someone's doing some loud stuff just outside this window. Okay. Do you still need to prove general formulas? You should do some sort of proof, I think. It doesn't have to be a proof by induction, which you might or might not know. It's really like 1c. There's a trick for 1c. The trick for 1c is the difference of two squares. That this object here is the difference of two squares, square minus square. So it factorises like this, -1 times 199. If you do that on pairs of terms, then you get a nicer series. This series is a bit hard to add up, but if you difference of two squares each pair of squares, then you get a nice series. What do I do about self-taught A-level students trying to join Oxford undergraduate in their 30s? There's some advice about mature applicants. We will look at recent achievements, recent academic stuff that you've been up to, recent things you've been doing. If you've done some sort of, I don't know, Open University start of a course or something, or if you've looked at other bits of mathematics, we'll look at that. We know that that's more relevant than whatever you were doing at school 15 years ago, or whatever it is. Okay. BMO 1, we don't compare people's scores on BMO 1 because not everybody's done it. We have the MAT. Not everyone knows about BMO 1. Do I think people will do better on this year's MAT? I think you personally will do very well on this year's MAT. What university did you go to? I went to Cambridge. People want to do 1E with chat? Do we do 1E? 1E? 1E. Yeah, okay. 1E. Cool. I would draw a picture for 1E. I'll draw the picture and then chat can talk about it. There's the picture. A is positive. This is A squared. We would like this area. Okay, and chat is going to tell you how to do that question. Becca says, they found the live streams helpful. Thank you. Oh, thank you, Becca. Thanks for coming along. We couldn't have done it without people watching. I mean, probably could, but I probably wouldn't have done it without people watching. Okay. How do I recommend to learn about recursion? We did a live stream about recursion 3 weeks ago. So if you want to start there, you could look at some stuff about recursion there. We've got some math problems about recursion and some warm-up stuff, some chat with, I've got a computer science student on. She talked about recursion with us. You could look at that if you like. Otherwise, there's lots of good past math questions with recursion-y sort of ideas in, including this one on question 6. They're all quite logic-y, there's some logical idea about why some relationship holds. Process for applying for university from now until I take the maths. You're in year 12. Hello, year 12s watching. I feel like from the questions there might be lots of year 12s watching, so I'm going to do the overview. So you apply by, the deadline for Oxford's applications is the 15th of October. You do something called a UCAS application, where you tell us about your previous education, your qualifications, what qualifications you're currently studying, and you get a referee, so usually a teacher or tutor or somebody, to write a little short reference saying that you're great at mathematics, I guess, and giving us any extra context around, oh, this person goes to school, amazing person in our school's never seen people who are great at mathematics except this person, or something. It doesn't have to be that extreme, I'm sort of joking, but that's the components that we get. You also register to do the maths, and then you take the maths. and we get hundreds of applications. We get everyone to take the MAT, and then we decide who we're going to shortlist for interview. We do the interviews. They're more maths questions. We do those in early December, inviting people to interview, either online like this year, or hopefully next year in person maybe, to do some maths questions. We decide who to make offers to. We make those offers in January, and then people get the grades to meet the offer. We have some standards on our website about what we're looking for. But really that's a formality of sort of stay in school or equivalent and get the grades and then start the course. That's kind of it. Apply on UCAS, register for the MAT, do the MAT, some interviews happen, we make offers. Why do we have some small computer science? We've got quite a small computer science building. If you would like to give us £100 million to build a bigger computer science building, then that'd be great. We're trying to expand the number of computer scientists as well. People teaching computer science as well. We know that computer science is very popular and very important. Good. How do you practice for 6th and 7th? There's some resources on the computer science web page. I will link you to them after I'm not live. Check your comment after we're not live, and I will post a link to computer science recommend the Bebras challenge for extra problems, and then embarrassingly they also recommend this live stream. Cool. I got 0 marks on BMO 1. I couldn't answer a single of the questions. Okay, yeah. BMO 1 is a bit different. It's not exactly like university mathematics either. Gold medal in IMO, help when applying to Oxford. Probably means you're quite good at mathematics, which is the important thing. So the medal's not like a key, but getting the medal probably means you're good at maths, which is then the thing that I'm actually interested in, right? Is not what jewellery do you own, but what maths can you do? It's kind of... Oh, that was a bit dismissive, wasn't it? I never qualified for any IMO stuff. I'm really excited that you enjoy doing maths questions. Cool. Oh, chat. Thank you, Zach. Chat's reminded me. We're doing the thing. George is there too. Got to work out what this point is, says George. And Zach's got a plan to do the integral and then subtract. Becca has a clue. I like that clue. Becca's still here. Bit of differentiation, bit of integration, and the area of a triangle. How big are triangles? Hi everyone, how big are triangles? There was a step question I marked once, back when I was at Cambridge and marking step papers. And the big chunk of the question was, how big is this triangle? But the triangle was lined up. One of the sides was parallel to the y-axis, and then a corner was somewhere else. And that really confused people. It was quite hard to mark because it confused people so much that the base of the triangle was vertical. Step question. Cool. Am I allowed to talk about step questions? Probably. To the area. Oh, that's a very detailed solution. Okay. That's a detailed clue about where the triangle is and what to subtract. Are Year 12 students statistically disadvantaged? I mean, if you're currently in Year 12, then you've had your education disrupted by a pandemic. So yes, I think. Unless you mean like compared to Year 13 students, in which case are you disadvantaged by being younger? I don't quite get the question. Bye, anonymous person. If you apply after 3A starts. Okay, so if you've already made the grades, in my little look through at what happens, if you've already made the grades, then when we make the offer we go, oh, this person's already got the grades, so we don't need to ask them for any grades. That happens sometimes. And sometimes they took the grades ages away and they're doing something else more recent, so we're saying, well, okay, stay in school and do this recent thing that you're doing and get the grades in that, even though 20 years ago you got some other grades. But yeah, cool. Oh, Aki's got a solution here. Big paragraph, I like it. Took the integral, subtract. Yeah, I think people have done this question the same way as each other, which is also the way I've done it in the 2-hour video. Do I look at your personal statement and references? Oh, when do I do that? With your MAT paper. So we kind of wait. Well, I guess we've got them at the moment. So tutors could be looking at them now. Could look at them ahead. But yeah, could be reading it now. Or we could be waiting for MAT scores and then look at everything together. The MAT scores are kind of so important that just reading people's applications, you know, I kind of think, well, this looks nice. They're keen on mathematics, but I'd like to see them actually do some mathematics. And then you read the next one, and you kind of think the same thing, and you want to find out that one of them's better at math than the other. And that'll really help me make this decision. Past papers that are really old, do they help? I mean, they're maths questions, right? And doing maths questions is helpful. But I never really recommend that people do all of them. From my point of view, right, there's more and more past paper questions, so it gets more and more ridiculous for me to recommend doing all of them. I never really want that. Do you have the key? No. No key. I go all around the room, but I never leave the corner. What am I? Never leave the corner. Is it some sort of angle? Is it? Oh, I don't know. Angles? Good fun. Right, cool. How many applicants does Oxford get? Oxford's got about 23,000 applicants for everything, if that's the question. Good. When do I look at it? I'm looking at it maybe now or maybe after MAT. Can I apply to Oxford midway through the year? No, sorry, we only have one round for the undergraduate courses, just one round, 15th of October, applying for the next year. We do it. That's when we do it. Once a year. If you get COVID, then maybe you're isolating, so maybe you don't get to take the MAT, and we'll have to make the decision based on the rest of your application. If you're in year 12, then are you applying to do? You're applying, but you haven't finished year 13. You haven't finished your school stuff yet. If you're in the UK where the years go up to 13, then you've got a whole extra year still to go. So are you applying with deferred entry, or am I making this more complicated? I don't understand. If you apply when you know less maths before you're ready to go to university, then you're not ready to. Most people don't apply in year 12. Most people apply in year 13. Cool. Good. Cool. I'm gonna wrap this up. Oh, it's a stamp. It's a stamp. There we go. Good. Right. I think on that note, on this note, boom, 100 milli. If I charge applicants £5,000. I'm not going to do that, obviously. Right. Cool. I think I'm going to wrap up there. Chat's got great suggestions on how to do 1E. It's a little bit after 7, so I'm going to wrap up the live stream. Some people's questions, I didn't answer them live. Sorry if you watched the whole video waiting for me to answer your question. I'm going to type some answers to starred questions in the Slido chat. If you're watching the replay, the Slido stays open for a little bit afterwards. If you're watching this months from now, then wow. Well done for watching the video. I don't know how you're going to get answers to these questions. Maybe email us on that email address that's in the description. Have a nice evening, everyone. Take care. Bye. How do I stop this one? And enjoy the MAT next week. And I'll see you next week for not MAT questions, talking about other sorts of mathematics. Same time, 5 o'clock next Thursday. I will understand if nobody wants to come to that. If you do the MAT and never want to see Oxford stuff again, then that's fine with me. It might be a little cosy, smaller live stream next week, just talking about not MAT stuff. If you're just here for MAT, that's obviously fine. Right, okay. That's enough from me, I think. Take care. Have a nice evening. Bye.